On problem 13, we want to rewrite these so they both have a base of 5. I want the same base. And let me make this a little bit bigger so we're just looking at this. So 25 I can write as 5 to the second power. I'm going to take that to the x minus 3. That'll equal 5 to the fourth power. Using my power of a product, multiply my exponents. That's 5 to the 2x minus 6 equals 4. 5 to the fourth. Sorry about that. Now my bases are the same. So that means my exponents are the same. So in other words, 2x minus 6 equals 4. I can solve that equation now. So I'm going to say 2x minus 6 equals 4. Add 6 to both sides. 2x equals 10. I'll divide both sides by 2. And x equals 5. And that's what I was asking for in that question. Okay, now, select all the statements that is true. If m is 1, then m to the x is 1. That is, 1 to the x will equal 1. Well, that's always true, isn't it? No matter what number I pick for my exponent, 1 to the 50th power is 1. 1 to the 0 power is 1. 1 to the negative 5 is 1. So that one is going to always be true. M to the x equals negative m to the x. That's not true, because if x was odd, that won't be true. Now, if m is bigger than 0, and m does not equal 1, then m to the x equals m to the y if and only if x equals y. Well, that seems like that should be true, shouldn't it? We might come back to that later on, but yes, that's going to be true. Now, how about if x equals 0? Because I know it says m is bigger than 0. Now it says m to the x equals m to the y if and only if y equals 0. Well, since x is 0, anything to the 0 power would equal to 1, wouldn't it? Now y, we're saying if y is 0, that's going to be true. So I think that whole thing is true also, because anything to the 0 power is 1. Trying to think of a counterexample in my head here that would not necessarily be true, but I think that's always going to be true. So that one's always going to be true. Okay, how about the third one? If m is 1, then m to the x minus m to, well, we already just said if anything is to the first power, or 1 to anything is 1, isn't it? So 1 minus 1, that's always going to be true. So all three of those are true there, aren't they? We have 4 of the 5 are true. Okay, 15. Once again, I got to get the same base to do this. And I can't think of a number that I can take 9 by that will give me 27. So I think less than 9. Oh, 3. So if I write 27, that's, whoops, I got my highlighter on. That's 3 to the third power. I'm going to raise that to the x minus 1 power. I'm going to raise that to the squared power. And then 9 is 3 to the second. I'm going to raise that to the 2x minus 2 power. Well, then I'm going to multiply my exponents here. 3 times 2 is 6. So I'm going to get 3 to the 6x minus 6, because I'm just multiplying my 3 together. 3 times 2 times x minus 1, I get 6x minus 6 equals 2 times 2 is 4x minus 8. Now it's kind of like question 13. I'm going to set them equal to each other. I'm going to say, oh, 6x minus 6 equals 4x minus 8. Now I'm just going to do my arithmetic. I'm going to subtract 4x from both sides. And I will get 2x minus 6 equals negative 8. I'll add 6 to both sides. 2x equals negative 2 divided by 2. X equals negative 1 is what we should get for an answer there. And then the challenge, we got to do that one on our own to make that true.